Today on Smart Pointer series. Today I'm going to discuss about unique pointer. So what this unique pointer is, we will go through few examples, and this tutorial is divided in three sections. First is I will discuss about the creation part, how we're going to create a unique pointer, and then I will explain you how to delete a unique pointer, means forcefully release the memory. And third is how we're going to pass unique pointer to different function across your program. So first we jump to the creation part, and we will see through examples how we're going to create a unique pointer. Example, created a class test. Okay, in this test I have created one constructor in which I printed constructor called, and there is a disk constructor, and there is a cout here, and there is a print function which simply prints hello world. Okay, so let's first understand the old way of creating an object. Okay, so what you will do is set test t is equal to new test. Fine. So this is the way of creating allocating a memory for a new object. So how we are going to create through unique pointer? The first way is pointer and the type of class and t and new test. So the first syntax is the type of smart pointer and the class name, and you pass a new object here inside that inside this instance. Okay, instead of unique pointer. So in this way a wrapper is created for this raw pointer new test, and unique pointer from here will take care of that. Okay, so if you you can call the function in normal way like raw pointer. Okay, if I run the function, run the code, one second. Sorry, there is spelling mistake here. Unique, yes. So if I run the code, then you can see first the constructor get called when you allocated a new memory, and there is a hello world when you call the print function, and it automatically deletes this object when you go out of scope. So destructor get called. So the difference between old way of allocating memory through new and unique pointer is unique pointer automatically takes care of the memory management part. It automatically deletes the object when you go out of scope. Whenever we go out of scope of this block, then it automatically deletes the. Let's understand through local scope. So I have created a one local block, and before block I have printed before block, and after block. So let's run the code. We can see that first before block got printed, and then constructor get called because you have new test, and then print hello world get called, and then when this block code go out of this scope of this block, it automatically destruct the object, cause the deletion part, so free the memory. So we see that whenever the variable unique pointer go out of the scope of the block, it automatically release the memory. So this is the beauty of a smart pointer, especially the unique pointer. Okay, and then after block get called. This is the one way. The second way for creating is unique pointer test t equal to make unique and test. So this is the second way of creating the unique pointer. Just let's run this program. Okay, you can see that there is no difference in the output. There is before block, then constructor get called, and there is hello world print, and finally when the code go block out of this scope, then automatically delete the unique pointer and releases the memory. So destructor get called, and then finally after block. So there is no difference in execution of code, but it's highly recommended to use this format for creating a unique pointer. There are multiple reasons for that. The first reason is this is more optimized code than this one. Okay, and make unique also handles the exception part. When you are creating memories and some exception comes, then make unique will handle that part. Okay, here it is not handled. And third is, since we are a smart pointer, we are avoiding new and delete keyword for allocation or delocation. So it's a standard way of this syntax helps you to avoid the new keyword. So these are three main reasons you should always consider to use make unique pointer to create a unique pointer. So this is the creation part. Now we'll go to the deletion part, how we're going to delete a unique pointer. Okay, we will see how to delete a unique pointer. We all know that smart pointer automatically takes care of the deletion part, but in some scenario if you want to force the deletion, there is a way. Okay, so in this example I will show you how to delete. So this is unique pointer, t is unique pointer. Okay, and I've called that print function. To delete this unique pointer before system deletes it, you can assign it to null pointer. Okay, so in this way it will force the unique pointer to go deallocate the memory. Let's see through examples. Okay, let's before assigning null pointer, let's print this the value of the t is unique pointer before null. Okay, t dot get. So t get function just give you the actual row pointer stored by this unique pointer. Okay, so after null, before and after. Okay, so if I run this code, you can see here the constructor get called because we have created a new unique pointer, and then hello world print function, and before null you will see that there is a address of pointer stored in the unique pointer. Okay, and when you assign the null pointer here, it automatically delete that node and destructor get called, and after null you see there is a 0. So there is 0 stored in the t right now. So you can see you can force the deletion call. It is not used in most of the places, but it's a way to delocate the memory forcefully. So now we'll go to the final section of this tutorial. We'll check how to pass a unique pointer across function in a program. Okay, so let's jump to the third section. You can pass a variable to a function either two way. First is by value or by reference. Okay, in C++. So for passing the value you need kind of assignment operator get called. So but in unique pointer assignment operator is not allowed. So let's check through example t2. So I have created a new unique pointer t2, and if I try to do assignment here, like I want to assign t to the t2 just to pass the reference, sorry, the row pointer from t to t2. Let's see it's allowed or not. So let's compile the code. So you can see here there is lots of error coming. So if you read the last error, it says that assignment is not allowed. So what it says that assignment is not allowed in new pointer. It holds the principles that only one ownership is allowed. So it means if t is owning some row pointer, it cannot be passed to t2. Means both cannot point to the same row pointer. So what is the solution for this? You need to use the move function here. So there is a move function available here. The move what basically does is it basically transfer the ownership of the row pointer held by this unique pointer to t2. So now let's run the and call the function print function here. Can t2 is equal to move t, anything wrong here? no, not, sorry, here capital T, right? Okay, so you can see here now you can easily call the T2 function. Now here you can see T has released the ownership and the ownership passed to the T2. So now T2 has access of that row pointer. You can print and check that thing. So before move, let's print out the what T holds. Before move T, let's print what T holds. Okay, and after move, let's see what T holds and T2 holds. T and T2. Let's remove this function. Okay, now if you run this program, you can see here when the constructor called before move, you can see T has some random address, so it says that it's some pointer address is there. After move, you can see the T is assigning to null, nothing is stored there. In T2, okay, let's sorry, it's T2, right? Okay, so you can see here after move, T holds null and T2 holds the original pointer. So you can see here through direct assignment is not allowed, but through move function you can transfer the ownership. Okay, so now we are going to understand the call by value and call by reference function for passing the unique pointer to different functions. Okay, so just clean up all the things. Write a function here, void myfunc unique pointer test local loc, and they call the function print. Okay, if you try to pass T here, okay, you will get the same error that assignment is not allowed, because the assignment update is deleted from here. So you cannot simply, because this thing T get copied on the LOC, this is not allowed directly. So what you can do is you can need to use the move function. See, her constructor get called, hello world, and instructor called. So what you are doing is you are transferring the ownership from T to this local variable, and then local variable calls the print function. So this is the call by value method for passing the ownership from your main function, your one function, to another function. The second way is through reference. Okay, so let's copy this function, my function ref, and ampersand so since you are passing the reference, you no need to copy the content, right? So there is no, so copy content is not required here, so that's why you no need to call the move function here. So let's call the function, let's run the program. See, the functions is running correctly. So there are two ways. One is either you are making a copy, then you need to use the move function here, and if you are passing through reference, then you just need to use the old way. But this breaks the rules of original unique pointer, that only one unique pointer should hold the ownership of the row pointer. So this system bypass that, so it's not recommended. So you always use myfunc way. Always move the content from original unique pointer to the local pointer, second function. So this is good way of programming unique pointer. Okay. So this is the final section of this tutorial. Hopes you understood all these things. So thank you for watching my video. For more video, please like and subscribe to our channel.